if you were out for Take Your Child to Work Day, this is the lesson that you missed for April 27th in Algebra 1, Part 1. Okay, so in order to find the theoretical probability of an event, you have to find the total number of favorable outcomes over the total number of possible outcomes. The total number of possible outcomes is called the sample space. And there's many different ways of finding the sample space, and that's what we're going to go over today. One way is to list possible outcomes, another is to make a tree diagram, and the other is to use the fundamental counting principle. And that's what today's lesson is about. Now, suppose if you turn to page 6 in your packet, example 1 says, suppose you were asked to find the probability that two girls would order the exact same lunch. It would depend upon the possible combination of lunches that were available. So we are going to find out the sample space, but we're going to find the sample space using 3 different methods. One method is listing possible outcomes, the second method is using a tree diagram, and the third method is using the fundamental counting principle. Okay, so here we see that the possible, when you choose a sandwich, you get to choose the type of bread, the type of meat, and the type of cheese. Now, if we were to make a list, we could make a list by saying, okay, I'm going to list all the sandwiches we could make with rye bread. We could have rye, turkey, American. We could have rye, turkey, cheddar. We could have white turkey American. We can have white turkey cheddar. We can have whole wheat turkey American. Whole wheat turkey cheddar. So 1, 2, 3, 4, 5, 6 combinations using turkey. So now let's use the ham. We can have rye ham American, rye ham cheddar, white ham American, white ham cheddar, whole wheat ham American, whole wheat ham cheddar. Finally, we could have roast beef. So it would be rye beef American, rye beef cheddar, white beef American, white beef cheddar, whole wheat beef American, whole wheat beef cheddar. So there's a total of 18 possible outcomes. So one way to get the total number of possible outcomes is to just list them, as I did. Now, another way we could do it is we could use a tree diagram. Now, want to get the list? Okay. Now, when we do a tree diagram, we have what I consider 3 events. Your first event is choosing a bread, let's say. Okay? So, event 1. And that's way too big. Okay. We'll call it here. Event 1 is choose a bread. So I can choose either rye, white, or whole wheat. Now, once I've chosen a bread, now I'm going to choose a meat. So, if I choose rye, I can either have turkey, ham, or roast beef. If I chose white, I could have turkey, ham, or roast beef. If I chose whole wheat, I could have turkey, ham, or roast beef. That's considered event 2. Event 2 is choosing your meat. Turkey, ham, beef, turkey, ham, beef, turkey, ham, beef. Okay? Now, event 3 is choosing your cheese. So coming out of each of these will be 2. And on each of these, I'm going to have American cheddar, American cheddar, American cheddar, all the way down. Now, the advantage of this is as I follow the branches, I could list the different possible outcomes. Rye, turkey, American, rye, turkey, cheese. Rye, ham, American, rye, ham, cheddar. Rye, roast beef, American, rye, roast beef, cheddar, etc. So if I count up the number here, I get 18, which is the same as I got using the other method. And this is called a tree diagram. Now, the final way we can find out the sample space is called the fundamental counting theorem. Now, here, how many choices do we have for bread? We have 3. How many choices do we have for meat? We have 3. How many choices do we have for cheese? We have 2. And if I do 3 times 3 is 9 times 2 is 18, which is another way of finding the total possible outcomes. Now, this is obviously the quickest and the easiest, but does it list the possible outcomes? No. So this would be a good method to use if you just needed to know how many outcomes there were, not specifically what the outcomes were. Okay, now, if we continue on page 6, we are going to list the possible outcomes for us tossing a coin. Just one coin. Well, if I toss just one coin, there's 2 possible outcomes, heads or tails. But if we turn the page, it says, well, what if you toss 2 coins? Now, even if you toss 2 coins at the same time, it's considered 2 events. Event 1 would be how the first one falls, and event 2 would be how the second one falls. So, for the first one, I could get heads or tails. Whether I get heads or tails, the second one, I could also get heads or tails. So this means I could get heads, 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 tails, tails, heads, or tails, tails. So I could get 4 possible outcomes, and I listed it using a tree diagram. Now, it says use the fundamental counting principle to find the total number of outcomes. Well, to use that, I say, how many outcomes do I have for the first coin? 2. How many outcomes do I have for the second coin? 2. 2 times 2 is 4, so I have 4 possible outcomes. Again, using the fundamental counting principle is the quickest and easiest, but it doesn't list your possible outcomes. Now, we're going to do the same thing for rolling a a 6-sided number cube. Okay? So now, for my number cube, okay, you see that I say list the possible outcomes. Well, your possible outcomes, if you roll 1, is a 1, 2, 3, 4, 5, or 6. That's pretty easy, we just list it. But now suppose you roll 2. Your number of outcomes increase greatly, because how many outcomes do I have for the first roll? 6. And then I multiply it by how many outcomes do I have for the second roll? 6. So according to the fundamental counting principle, there should be 36 possible outcomes. But now I give you a chart on page 7 to help you list the possible outcomes. So we put what we could get from each coin, and then if I roll a 1 and a 1, a 2 and a 1, a 3 and a 1, a 4 and a 1, a 5 and a 1, a 6 and a 1. Then I get a 1 and a 2, a 2 and a 2, a 3 and a 2, 4 and a 2, 5 and a 2, 6 and a 2. So you should fill this out. That's a 4 and a 5. Okay, and that lists our 36 possible outcomes. Okay? So now, if you turn to page 7, we're not actually going to do this, but if you look at the trees, I could roll a 1 on the first, then I have 6 options for my second. But this shows you the 36 possible outcomes. Okay. Now, we look at page 9. Let's try to answer some questions. So on page 9, it says, Lindsay flips a coin and rolls a number cube 1 through 6 at the same time. What are the possible outcomes? And they have started the possible outcomes. Now, you could get heads and 1, heads and a 2, heads and a 3, heads and a 4, heads and a 5, heads and a 6. You could also get tails and a 1, tails and a 2, tails and a 3, tails and a 4, tails and a 5, tails and a 6. So the possible outcomes, if I use the fundamental counting principle, if I flip a coin, I have 2 possible outcomes. I roll my die, I have 6 possible outcomes, 12 possible outcomes, and they're all listed there. Okay, the next one says, Jordan has a choice of wheat bread, rye bread, a choice of turkey, ham, and tuna. What are the possible choices of sandwiches he can have? So you can just list this as wheat, turkey, wheat, ham, wheat, tuna. Then you could have rye, turkey, rye, ham, rye, tuna. And we end up with 6 possible outcomes. Let's see if the fundamental counting principle agrees with us. Choices of bread were 2. Choices of meat were 3. Get a total of 6. Okay. Now, go ahead and try to do 3, 4, 5, 6 on your own. Stop the video, and when you're done, see if you agree with the answers. Okay, that's all we did in class for 6 through 9. And there's going to be another video for 13 through 15.